Hey everybody, this week is all about solving two-step equations. So we have a few learning targets. You will be able to find a solution to an equation by reasoning about a diagram. You'll be able to write equations based on diagrams and on story problems. And you'll be able to find a solution to an equation by reasoning about what value would make that equation true. And of course, by using inverse operations. We're going to start with some context and story problems first. So let's take a look here. It says May made 50 flyers for 5 volunteers in her club to hang up around school. She gave 5 flyers to the first volunteer, 18 flyers to the second volunteer, and then divided the remaining flyers equally among the 3 remaining volunteers. This diagram is called a tape diagram. And it's another visual to help us solve some story problems and, of course, some equations. So breaking it down, we can see that the total is represented here by the whole tape diagram, and it says it's labeled 50 because she made 50 flyers for 5 volunteers. So notice there are 5 different sections of that tape diagram. She gave 5 flyers to the first person, 18 flyers to the next person, and then divided the remaining equally, right here, to those last 3 volunteers. So hopefully you can kind of see the story problem broken down into this diagram. We can, of course, write an equation that represents this. So we could do 50 equals 5 plus 18 plus 3 groups of x. And then we can simplify it and figure out what the x is. But of course, one of our learning targets is, can we reason through using a diagram? What do you think we would have to do first? Okay, we would have to take away whatever 18 plus 5 is, which is 23, right? We would take away that and then divide what we get among the 3 left over. For the sake of just this story problem, we're not going to necessarily solve these in the beginning. We'll get to solving later, but I just want to show you how we can use a diagram to help us figure out some unknown values. And the unknown values, of course, are how many these 3 volunteers got. Okay, so let's take a look at another one. It says May distributed another group of flyers equally among the 5 volunteers. So this time, all 5 people got the same amount. Then she remembered she needed some flyers to give to teachers, so she took 2 flyers from each of those volunteers. Then the volunteers had a total of 40. Notice the total of the tape diagram is 40. What we don't know, or what the variable represents, is how much each of those volunteers got, right? But what we do know is she took 2 flyers away. That's represented with this -2 idea. Okay, so 40 flyers total. There are 5 sections of this tape diagram representing the 5 volunteers. They each got so many flyers, right? The W, but then she took 2 away from each of them. And that's why we're seeing the same thing in each of those sections of the tape diagram. I'm wondering, could you kind of think to yourself, how would you figure out how much each volunteer got? Okay, last one. It says Noah and his sister are making gift bags for a birthday party. Noah puts 3 pencil erasers in each bag. His sister puts X stickers in each bag. That's our unknown. We don't know how many she put. After filling 4 bags, they have used a total of 44 items. There's our total. 4 bags, 4 sections, because they're all the same. Okay, he put 3 pencils in each bag, and then his sister put so many stickers in each bag. Okay, so I'm thinking, if I was to write an equation, 44 equals, let's see, I could do 4 groups of x plus 3. That could be one version of the equation. There's more that work too. Someone could write x plus 3 plus x plus 3 plus x plus 3 plus x plus 3 equals 44. That'd be a long version of an equation that works. Someone could just say, let me switch colors here. I'm thinking someone else could even do, looking at the whole thing, there are 4 x's plus there would be 12 total pencil erasers for a total of 44 total items. Okay, so many different ways. And then, of course, the ultimate goal is to figure out that unknown, which would be how many stickers she put in the bag. And we can reason through the diagram. We can reason through the equation. Okay, so many options. Okay, so now hanger diagrams. Remember those from last week? We can also use those to figure out like those unknown weights. All right, so looking at this one, I noticed there are 7 weights or 7 pounds, I'll just call it, on the left side. And that is balanced or equal to 3 W's plus 1. Do you notice how these equations look a little different from last week? There's just an extra thing going on, right? So I'm thinking about our learning target still, and I could let's just focus on reasoning through using the model, okay? And we'll get to just the steps in a second. But knowing what we did last week and trying to figure out what one of the W's represents, if I took this weight off on the left side, I would make it unbalanced, right? But if I did that same thing over here, it would balance back out, okay? And then now I'm left with 6 on the left and just 3W, right? Because what I did here, I'm just going to give you a little preview. I took away one weight over here, and then I took away one weight over here, right? What we do to one side, we have to do to the other. And then now I'm at this second equation. So 6 equals 3 times x, W. And, I think we saw this in our VC last week. And many of you shared out, you were just thinking, well, the 6 would have to be divided by the 3, and W would equal 2. And we could check it because if we were to test it out, it would work. 2 plus 2 plus 2 plus the 1 that was there would be 7. And then it equals the 7 over there. So it works. So we can reason through using this hanger diagram. Let's take a look at another one. Okay, so I've got 2 z's plus 3 on the left, and that is imbalanced or equal to 5. Do you notice anything with this hanger? Look at this. I'm noticing that there's the same amount on each side. So z equals 1. And it works because if z was 1, there'd be 5 weights or 5 pounds on that side, and it would equal the 5 pounds on the right side. So again, we could just draw a picture to help us too sometimes with these equations to figure them out. Okay, let's take a look at this one. We've got 3 x's plus 2 more on the left side, and that is equivalent to 3 on the right side. So, I'm thinking the x is not a lot of weight. I feel like it's even less than like a pound. Let's see what happens. Okay, I only want to know what x is, so I'm going to take away these 2. If I do that on that side, I have to do it on the other side. Okay, so again, just to show my thinking along the way, I took away the 2 on the left, so I got to take away the 2 on the right. Okay, so then, this is weird. 3 groups of what equals 1? What kind of number are we going to get? Definitely a small one. I'm thinking fraction. Are you? Hmm. I have three groups of something equal one whole. So if I were to go back to my steps, I have to divide that one into three groups. Or excuse me, sorry, the other way around. I have to divide the 3 by the 1. Oh, I think I know. Each of these would be a third, and how it shows up here, again, I divided it by 3, so I had to divide it by 3. X equals a third. That makes sense to me because I knew it was gonna be less than 1 full pound, right? Okay. So what I've been, oh, one more, sorry. Getting ahead of myself. Look at this one. This hanger diagram, there's 14 total pounds on the left side, and then they're split into 2 groups. So I wanted to show you connecting it to the distributed property. There's this equation works right here. It's showing 14 equals 2 groups of x plus 3. Do you see it? Here's an x plus 3, and here's an x plus 3. Or you can also think about it, someone might write it like this: 14 equals 2x's plus 6. They are combining like terms, right? Using the distributed property from a couple weeks ago and just simplifying it like that. So again, we can kind of think about it in different ways. We could take away the 6 pounds over here, right? And then take away the 6 from there and then narrow it down to 2 groups of x equaling, you know what? Someone might even say, well, if the right-hand side is 2 groups already, then if I were to split this weight, right, it'd be 7 and 7. So 7 would equal x plus 3, right? Half of each side, and then figure it out from there. So many different options. Take a look at this slide real quick because this is kind of what I've been modeling as far as my thinking along the way. I'm taking away some weights first, then I'm kind of dividing into equal groups, right? There's multiple ones. So here are the steps that we follow to solving these two-step equations. They're called two-step equations because there's like 2 operations happening. Last week, there was just 1 operation happening. Let's put this into practice. Okay, so notice the steps look very similar to last week, but couple things have changed. So the first one, in the expression with the variable, what we want to think about, what operation is taking place, or what are the signs of the constants. We want to focus on that first. And then step 2 is we want to go in the order of we want to unravel or undo the addition and subtraction first by using the inverse operation. Then we have to undo the multiplication or division using the inverse operations. Okay, it's like the order of operations backwards because that's what we're doing. We're working backwards to solve a puzzle, an unknown. And then last step 3, remember to keep things balanced always, right? What you do on one side of the equal sign, you must do to the other. So let's, I just want to kind of show you what this looks like in action. So my first problem, I'm going to draw my divider here among the equal sign. Again, I'm just separating left side and right side. And step 1 tells me I want to focus on the constant first. So there's that 10, the 10 weight. I want to get rid of the 10 weight. If I do that over there, I have to do it over here. Then I'm left with 3 groups of K equaling how many pounds or how many weights over here? Well, 22 take away 10 is 12. Okay, so then I have 3 groups of something equals 12. So unraveling that or undoing that multiplication, I'm going to divide by 3. If I do that over there, I have to do it over here. And final answer would be K equals 4. If I were to plug it back in and test it out, okay, so pretending K is 4, 3 times 4, I would do that first, because again, order of operations, right? If I'm simplifying something, that would be 12, and then plus the 10 is 22, and I know I got it. Let's take a look at the next one. Okay, here's the variable. So I'm keying in on this whole -5 idea. There's the constant, it's like a -5. How do I undo that or reverse that? I add 5. That equals 0. If I added 5 over here, I have to add 5 over here. So 19 plus 5 is 24, and that equals 4p, right? 4 groups of p. How do I unravel that multiplication? I use division. 4 divided by 4 is 1. That's what I wanted. If I did it over here, I have to do it over here. And p equals 24 divided by 4, which is 6. And last one on this slide. Here's my balanced hanger idea. Oh, okay. So here's the constant, the +9. I'm going to focus on that first. I'm going to do the opposite. That's -9. Got rid of it. Have to do the same over here, right? 32 minus 9. You can write it like that too. So I've got -4k equals, what is 32 minus 9? Well, 32 take away 10 would be 22. So that'd be 23. And then I have to, again, undo this multiplication. So I'm going to divide by -4. What's there? Because it would be +1, which I want. And then I would have to do it over here. And k equals -23 fourths, right? I can just leave it like that. You can turn it into a mixed number if you want. All right, let's take a look at some more. Hopefully you're getting kind of the gist. Okay, I'm going to focus on the constant. So that variable is right there. So this -8, I'm going to add 8. I'm going to add 8 over here then. So now I have r divided by 2 equals, what's 16 plus 8? That's 24. Oh, okay. So a lot of you said these ones were the trickiest for you. All this means is r divided by 2 equals 24. It's just another way to think about it, right? If my unknown is what I started with, the dividend, I know I started with a lot. If I then divided it by 2, right, and got 24, so that would be, I'm going to show my steps. I'd multiply that by 2, multiply that by 2, and r equals 48. Okay, over here. Okay, here's my variable. It's being divided by 2 plus 8, so I'll take care of this 8 first. -8, 0, -8 over here to keep it balanced. What's left is x divided by 2 equals, ooh, don't be tricked, -12 minus another 8 would give me -20. Okay, if it's being divided over here, I am going to multiply it by 2. Cancel it out, multiply it by 2 over here, and x equals -40. More examples. Woohoo! Okay, so this is just bringing in the distributive property because we don't want to forget that. We want to simplify things as much as possible, and then we're able to solve them. So here's my line. It's 4 groups of 5x plus 6. So I'm going to apply the distributive property first. I have 20 x's and plus 4 groups of 6 is 24. Okay, equaling 12. I want to do that simplifying first, and now I can tackle it using the steps. So here's my variable, here's my constant. I'm going to take away 24, so it's 0. What I do to that side, I have to do over here. And I've got 20 x's left over there, and 12 minus 24 is -12. And then to undo this multiplication, I'm going to divide by 20, so it equals 1x. And I'll divide by 20 over here. X equals -12 twentieths, right? Because division is just a fraction amount. I can just leave it like that, or I can simplify it. And last one. Oh, I love fractions. I bet you do too. Okay, distributed property. 2/3 times 3 x's. That would be 6/3 or 6/3 is 2. So 2x minus 2/3 times 6 is 12/3 or 4. Okay, minus 4 equals 8. Notice I simplified it first, multiplied the 2/3 by everything on the inside, and then now here's my constant, then minus 4. I'm going to add 4. I'm going to add 4. I've got 2x equals 8 plus 4 is 12. Divide out the 2, divide out the 2, and x equals 6. I know I can go back and plug it in and check just to make sure. And then we're going to end with writing an equation based on a story problem. It says Isabella's registering her son for swim lessons. There is a one-time $45 registration fee plus a $20 fee per lesson. Isabella paid a total of $225. Knowing this, how many lessons did she register for? So that is like my X, right? That's the question, that's the unknown. So how many lessons did she register for? And that appears right there in the story problem. Okay, I'm going to write this out. So she paid $45 just to even be interested in registering for any sort of lessons. Then she had to pay a $20 fee per lesson. That means $20 times every lesson that she signed up her son for. So $20 times however many they signed up for, and the total was $225. So there's my equation that goes with the story problem. Now, if I'm going to solve it, because I want to know how many lessons she registered for, I'm going to just apply my steps. So first of all, working backwards from her total, right? She had to pay the $45 registration fee. So that's my constant. And so I'm going to take away the 45 on both sides. Now I'm left with 20x equaling, well, 225 minus 45 is, let's see, 180. Let me see if that makes sense. 25, and 20 more or less. Yeah, 180. And then all I have to think about is 20 times how many lessons equals $180. Divide out the 20, divide out the 20, and x equals, what's 180 divided by 20? That would be 9 lessons. And there you go. Okay, so to sum up, I just want to emphasize that you can draw a diagram to help you solve equations. And you can also apply the steps to solving the equations, which were on some of those slides that we saw. Just keep in mind, since solving for an unknown is like solving for a puzzle, we just want to work backwards. And then, of course, we want to make sure our answer makes sense in the end. And we can do that by not only our number sense, but we can plug in what we get to see if it works.